Today I was planning on doing a video about this little circuit here, which is 4 AND gates made of relays. Actually, they are very similar relays to ones that I made in a previous video, but it occurred to me that in order to use this properly, I have to have a display on it, since I have to read the binary output for the AND gates. And since I have to make a display, I was going to use these LEDs. I have to organize these LEDs in a circuit though. And what better way to do that than on a cutting board. Cutting boards have been used for electronic prototyping since almost 100 years. They used to make prototypes for radios on cutting boards. They were actually how breadboards got their name. But those were on wooden cutting boards and not these plastic cutting boards, which I like to use for so many of my projects. I actually prefer these cutting boards over soldering just because I'm not very good at soldering and I usually break components or have to do some amount of reworking them. And these cutting boards are 88 cents each at Walmart. A prototyping board is more expensive than that usually, and you have to get it shipped in from Amazon or whatever website you use. With that aside, let's actually get to the problem we're trying to solve, which is making a circuit to have a display using little wiring. To do this, I want to arrange LEDs in a row. These are red LEDs. I also have white LEDs, but I'm going to try to just use these. What I'm going to try to do is I'm going to try to space them out in some way. Also, I need to have mounting holes to mount this to some sort of thing eventually. And for that, I think that these 1/4 inch holes that I previously drilled into it should be fine. Okay, so let's try to get these LEDs in this board. It's kind of confusing, but basically what I'm going to do is I'm going to put an LED in each one of these dots. We have 8 LEDs of the red kind, so we're going to put 8 LEDs there, and then we're going to use these bolts, and these are going to go on these little points at each of these marks. You can see how they're parallel to each LED, running in 2 lines. One of them is for the positive and the other is for the negative lines. So what I'm going to do is I'm going to stretch out the pins of the LED, and it will fit placed against this baseline. The bolts I'm going to use are number 6 by 32 threads per inch times 3/4 of an inch. You can see that I've spread out the pins of the LED. It will mount somewhere along here, and here, and here, and here. And I will twist the ends sticking out around the bolts. This requires that I drill out all of these holes and cut out along these 2 lines to free up our square, and also around these big holes here, 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 and here I will drill 1/4 inch mounting points so I can secure this device down. Okay, so you can see all the holes now are drilled out. Now we just need to cut it out. But you can see that some of the lines here are not exactly straight, but that shouldn't matter. As you can see, the bolts do pass through, and our whole idea should work just fine. There's plenty of leads left to mount our wires. So let's cut it out, clean up all this plastic shavings, and mount the LEDs. that we got this all drilled out, all the holes are drilled and it is also cut out, we can begin mounting our bolts and connecting everything together. So remember when I said that some of these lines are not exactly straight? Look right here. These two are touching. So that was a bit of a mistake that I made. But it's not really a problem since all of these I'm going to connect together as a common anode for the LEDs. Well, these will all be separated cathodes which will each go to their individual circuit. When working with LEDs, it's important to note that the long side is positive and the short side is negative, or the anode. So when we wire these, we want to possibly offset them a little bit closer to the negative side so they have equal length of lead on both sides. We have all our LEDs hooked up in their rows, and we are going to connect all the negative leads together with this piece of wire. You can see that it was I believe it's a 22 gauge insulated wire, and I just stripped back some of it and we're going to wrap around the edges. But before that, let's test and see if we got our wiring correctly. So what I'm doing to power this is I'm using a 3.3 volt source of electricity from a computer power supply, and that's going into this bolt with a bunch of, essentially it's an electromagnet, and that acts as a resistor which should bring down some of the power going through these LEDs. Let's test them out now. 3, 4, 5, 6, 7, 8. So all of them are hooked up correctly. Now let's just wrap this wire around and add the nuts and do the final test. Okay, so here's our final thing with all the wires going across and all the LEDs parallel to them. we have our one wire for the common ground and our positive wire coming off of a resistor going into one of these bolts. See, this one, 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 this one. You can make displays with them, going across and across. But what we're going to do is we're going to use this as a display for other projects. So if you have a project you want to do and you want to make a display without doing any soldering, this is a way to do it.